participant and the host. Let's keep our microphones muted unless you're ready to speak. And then let's make sure we're not in a noisy environment. Let's make sure to engage actively as we already have in the chat box. We already have been doing that. Samuel, Toby, and Faith are already engaging. So we'd like to see more people engage in the chat box. And if you want to talk, please raise up your hand and we would allow you to talk. Or if you have a contribution or a question. Let's keep the discussion on focus. And it should all be on topic. Let's also avoid spamming the chat with advertisements or topics that are not around what we're here for. Let's make sure to join this. Of course, most of us have joined, but to get the full impact, we will encourage that we stay till the end of the session so that we can get the full impact. Also, let's feel free to ask questions when it's time to ask questions. And then even if you have questions before the end of the session, please drop it in the chat box so that we'll get it ready for Larry. And then most importantly, let's connect. Let's be able to connect here. And maybe if you see somebody interesting, you can try to identify them and connect with them in the community by just maybe following up on WhatsApp. So we really look forward to this session, and especially because AI in the medical space is a very interesting topic, and it's no one, sorry. Particularly, I'm always very excited to hear what AI is doing in every other area aside from the tech space. Okay. Hi, Larry, if you are on the call and if you have joined, maybe using another person's device and you're on the call and we have not identified you, please, you can unmute yourself and let us know. Yeah. I'm supposed to read Larry's bio soon, and I really don't want to do it without her being here, and I don't want her to just come and just jump in. So this is the agenda for the session. Welcome, which we have done already, and then the main session, which will kick off after the bio. We're going to have the question and answer session as discussed in the ground rule that I just read, and also we're just going to announce and wrap up, and then maybe we're going to have some, if we have enough time back and forth about on our festive period and how it's going. Okay. So again, thank you for joining this session. This session is supposed to be, the topic is about building robust medical imaging AI for low resource setting, and it's going to be, we're hosting Larry Oluwakinye Abolade, who is a machine learning researcher, and we're really looking forward for this session, and just looking to see if she's joined. Sorry. Okay, not yet. Okay, I'll just go ahead and read the bio. Larry Olua is a machine learning researcher who is focused on medical imaging, robustness, and fairness in low-resource healthcare. I work on structure-aware pediatric X-ray and denoising, and Africa MRI segmentation has received recognition at the medical image computing and computer-assisted intervention workshops, and also had the neural information processing system workshop too. She's a passionate, she's very passionate about building inclusive AI system that addresses real world healthcare and equality, especially here in Africa. So let's see, that's not yet still. So feels awkward reading somebody's bio and they're not here. Especially when the learning will be the session. So comment, please. Okay. So while we wait for Larry, yes, we are doing that already, Samuel. While we wait for Larry, can somebody willing to share with us, like, especially in the AI world, what has been most interesting to them this year, and if you have something that you want to really work on or try in the year 2026 while we wait for Larry, maybe something exciting that you really want to work on that has to do with machine learning and AI. If you're willing to share, I keep getting kicked out. So yeah, is there anybody that just want to share about what they are really excited about, or what they are, yes, in 2025, and what they are looking up to in 2026? Okay. Okay. We're waiting on. Oh, EMC, more than happy to hear. You can unmute and share, please. You can unmute your mic and share. Hello, EMC.
All right. Hello, good evening. Thank you. Thank you. Sorry, I don't know your name. Thank you so much. And thanks to the host. My name is MC. I'm a radiographer, and I'm also interested in, AI tech in medical imaging or in the healthcare, basically. And okay, so personally for me, sorry, I'm coming. Yeah, all right. Sorry. So I said personally for me before joining this call. So I've been around AI, machine learning, like, you know, in COVID time, in quotes. So I was following the trend, but maybe because of school, I was in medical school, so I didn't really catch up with the trend. And somehow I just left that tech part. So for me, but although I still follow the AI trend, and there are a lot of, in fact, this year I noticed a lot of development in medical imaging, like so many AI tools that are being used in that space were launched, and so of course most of them are like out of the country. I've not really seen any for Nigeria, like markets. I don't know if anybody has an idea of. Okay, I think I've heard of one, but I'm not sure. I don't know how much they are really taking their products now. So yeah, so I mean, seeing this meeting today, I decided to join. I've been in the community, but I'm part of the spectators in quotes. So, but seeing today's topic, I just feel like, okay, let me join. Let me have an idea of, maybe to just kickstart my, tech life in code I've laid back, because it's look like I'm focusing more clinically now, but it won't be bad to have, understanding of what's going on now. And also, I was speaking with a friend. Okay, yeah, yeah, that's it. Thank you. Let me not take time. Thank you.
Okay, thank you so much. MC, really appreciate. Even though at some point we lost you because of maybe your internet, but um, thank you. I think we got the gist. Samuel said that personally, I just want to um, work on the right foundation. I'm also interested in AI research in industrial engineering. That's actually a very interesting my my work sense want to say department, but it's a very interesting industry rather, that the industrial engineering. Yeah. And I mean, I think as you just keep exploring, you will find a unique space. Who else want to, I mean, if you find a unique contribution to that space, Samuel. Who else want to share? Thank you so much, MC. Thank you so much, Samuel. Um, who else want to share? Okay. Oluwa Oluwatobiloba Akinusi. Then after that, we will have Dominion. Oluwatobiloba, please unmute your mic and let us hear from you.
All right. Good evening, everyone. My name
Good
I'm
evening.
Toby, and I'm a recent graduate of medical radiography. So this program is really, centered on the work I do. MRI is one of the modalities we use um, in imaging patients and all. So, but what I've learned about here, even before joining the medical radiography field, is that AI is going to make a lot of things faster, easier, and even better. And looking at how things are, looking at how the whole landscape of the world is, we see that some fields with AI are advancing better. I've seen how AI is used to, replicate human likeness, even in videos. There are platforms like Agent that you can upload, let's say, a 2 minutes video, 5 minutes video, and it will create an hyper realistic version of you that you can use for marketing visuals. You can use for those are very, very crazy, you know, um, products from AI. And we also have some other platforms like that. But I just want to see how AI can be used to make things work faster, make things easier for human beings. So that's I know we are all scared about the whole AI, and even in field of medical imaging, there is this whole AI is going to take jobs, and especially when we talk about radiologists who are the ones interpreting it. So AI is going to make image like that segmentation that you mentioned. It's going to make image reading image very, very easy, because it's going to highlight something that even human eyes is going to actually miss at that point. So I look forward to what it can do, and I look forward to this meeting especially. Thank you.
Yeah, thank you so much. I don't know if you guys can hear me. Oh, amazing. Yeah. Thank you for that. Um, and I'm going to address this comment here as well. Um, yeah, I I apologize for coming here a bit late. So I was in transit for a while. Just let me know if you can see my screen. Amazing. Okay, can you see my screen? Amazing. Thank you so much. Yeah, thank you so much, guys. Yeah, good evening, everyone, or maybe morning or afternoon, anywhere we are. Yeah, it's really amazing being here. I came in when they were introducing myself, so you people probably know a bit about me already. But yeah, today I'm very excited to be speaking about building robust medical imaging AI for low resource settings. Yeah, so I'm going to try to like should I say rush through what I have for us today, so that I'm going to cover like both the length and the depth of what I had to say. Um, let's see. All right, before I start, I'm just going to thank like the organizers of like ML Lagos and everybody that's like here today. Thank you so much for this wonderful opportunity. And yeah, so someone dropped the comment just like when I came around. Let me just put on my video so that you can see me while I talk. Yeah, so someone dropped like a comment about like, oh, this talk is for um this talk is for clinicians, it's not for clinicians or something in that line. And thankfully that's the first thing I'm addressing today. So this talk is actually for like researchers and engineers interested in medical AI for resource settings. So I think my talk is more suited for researchers because I'm a researcher, but then anybody looking to like just engineer anything in like medical AI or even low resource settings generally would like benefit from this talk. Also, clinicians actually just very curious about what AI can do or what it cannot do practically, and anybody that wants to build AI anywhere in the world, especially in Africa. So I think this talk is for every single person. So both researchers, engineers, and clinicians as a whole. Um, so I'm going to like rush this slide. My name is Liru Waki. I am an independent researcher at ML Collective. So I know a number of us might have heard of ML Collective before. But then under ML Collective, you can like generally come and I won't say do research practically. If you're looking to come into research, you can come around. So I currently lead the medical imaging focus group for ML Collective. And I'm a mechatronics engineering student. So I was also recently under Spark Academy. So Spark Academy is one of like the biggest medical imaging efforts in Africa here. So I think they also like pioneered the Brass Africa Challenge under Mikai. Um, and yeah, I love and attend a lot of conferences. Let me just like skip that. But yes, I was recently at Mikai and I was supposed to be at Neurus as well. So primarily like conferences. Um, let me. Oh, okay, all right, amazing. Okay. I feel like I just use it to get feedback from the audience. Okay, so yeah, I attended like Mikai and Neuro, so primary conferences dealing with medical imaging and AI. So I'm going to rush through this brief introductory slides. So I think yeah, if has anybody like ever gone to like Google to search their symptoms? Yeah, I okay. Oh, okay, I see. Yeah, so has anybody ever gone to Google to search their symptoms instead of a doctor? Let me find a way to do that. Don't worry, I'll make sure it doesn't cover anything useful. Yeah, so most of us have like just gone to like Google to search their symptoms instead of a doctor. So which brings us to why this is actually necessary. So in Africa, so most of what is on Google is like data trained with like data sets from everywhere around the world. So imagine like okay, there's let's say Google is oh okay, maybe I should share again if this is very urgent. 1 second. I mean, okay, let me just share this window. Um, okay, please let me know if this fixes problem. All right. Yeah, please just let me know if this fixes the problem. I don't know how. Yeah, okay, perfect. All right, thank you so much. Yeah, so imagine like Google is trained from data all around the world. So let's say now, imagine like having maybe like a skin rash or something, and then most of what is on Google is like just white people having rash and things like that. And then you're from Africa and you're trying to like just Google search what is wrong with you, and you're showing like your own skin that Google is probably not used to, and then just like posting it on Google, and Google is maybe like saying, yeah, you probably have cancer or something like that, just because you were not included in the training of like the models on it. Yeah, so yes, when we were most AI models, they assume that yeah, like there are high quality scanners everywhere. There is like data everywhere, stable electricity and internet everywhere, expert annotations or like homogeneous patient populations everywhere. But then there is bias everywhere. So I had like a few examples to just show like real life examples of like bias, but then I'm just going to like breeze through it. So I'm just let me just talk about this first example here. So in 2019 there was a study where there was an hospital that was giving like white patients more follow-up care than black patients, and they're not based on like their need but based on cost data actually. Maybe just because like Nigerians, let's say Nigerians don't, maybe they don't come like for follow-up a lot, mostly because of maybe like the cost of living here compared to how much you're earning. And because of that, like the whole study was just killed, and then white people were getting more follow-up care than black people. um so yeah, how do we build AI that actually works here? I think that's one of the center of things that I want to speak about today. Yeah, so let's say there's a model that's like, yeah, I'm going to save all your lives, and then a low resource setting, it's breaking down. So we want to look for ways to like yeah, like solve this problem today. So what is medical imaging AI? I don't know. I don't want to assume everybody here knows what medical imaging AI is about, so, but you've probably like heard it one way or the other. So then, medical imaging practically deals with different imaging modalities. So when you're thinking about medicine, but more about in the like imaging side of things, so consider MRIs, like X-rays, CT scans, ultrasounds. I don't know if anybody has like been under any of these scanners before, but then medical imaging AI is all about like things like this, but then using AI to maybe yeah, like classify them, disease or no disease, maybe like through an x-ray you're trying to see, yeah, does this person have COVID, does this person not have COVID, does this person have pneumonia, does this person not have pneumonia? So things in that line. Or segmentation, yeah, like maybe through an MRI and you're trying to see, yeah, where's the problem coming from? Or yeah, or enhancing it, because yeah, there's a problem in Africa once again. So enhance, I'll speak about this later, but then enhancement is like very necessary as well. Now, why this matters so much in healthcare? So usually imaging is the first diagnostic step. Maybe I should ask, is there anybody here that's in like maybe under a scanner in one way or the other, where you had to do like an X-ray? You can just thumbs up or something. Where you had to do maybe an X-ray an MRI, a CT, or anything in that line. Oh, interesting. A lot of people. Yeah. So So it is like very important. So let's say you're just going to a hospital, and maybe I think one of the easiest ways to just like look into your body is through imaging. So it's very important. And even in like low resource settings, I feel like a lot of imaging modalities are not as like available here, but we still use it a lot. Like imagine the number of people that have been under a scanner before, so it still matters like so much. Yes, I think we can come to this, but then robustness now, because my talk is about like building robust like AI for low resource settings. So robustness now, so there are a lot of problems in low resource settings that I'm going to speak about better later. But robustness practically, I don't know if you guys have heard before, but I feel like if you're doing research for low resource settings, you've probably heard of robustness a lot. But yeah, robustness just means like just building models that would not just work in like for um for Europeans, but they will also work for us here. So you're talking about things like clinical validity, model calibration, scalability, so things in that line. So I think this slide practically summarizes what it means, but the idea generally is to build models that also work for us here in like in low resource settings in the context of our talk today. Um, yeah, so there are core challenges that we're trying to fix with AI in low resource settings. So in low resource settings, now we are going to imagine Africa because this is ML Lagos, right? So we are mostly Africans. So the core challenges that exist today is, for one, data scarcity and bias. So I think recently I worked towards this challenge. Is sort of like an hackathon, but like a global hackathon in a sense. So you're doing like so there's this Brass Africa challenge. So where you try to like just build a segmentation model for African MRIs. Now, if you don't yet understand, it's fine. I'm going to like speak about these code challenges like better, like in a few slides to come. But yeah, so we have a problem. So there's like a lot of data from Europeans because most of them are just like more open to the AI movement, and then they just, I want to say they give data, but then yeah, so we have a lot less data than them. Like the African data sets I work with, we had like just 60 testing, 60 training data sets. While for the other like Europeans and other countries, they had like over 1,000, almost like 2,000. So the difference is just crazy. So the data scarcity here is a lot. And then another problem that exists here is like the image quality variability. So very funny thing, but if you look at an X-ray from like Nigeria, you're looking at an X-ray from USA, the difference is crazy. Like, yeah, imagine having like a stone in your, I don't know, in your ribs or something, and you're going to check here in Nigeria, and you're going to check in USA. You're going to easily see the stone there than like here, because of like the difference in in the image quality. There's also annotation limitations. So yeah, because I feel like there are a lot of clinicians out there, but in Nigeria, most of our clinicians, they've traveled, they've jackpot to be fair. So there's also like an annotation limitation. There's also deployment constraints, trust and adoption. If you meet like a Nigerian doctor now, and like if you're meeting like 10 Nigerian doctors and you're asking like all of them that which of you is open to maybe like using AI to just make your workflow better, about 9 of them will give you 100 reasons why they will never use AI. And the last one will just be like, okay, yeah, I'm probably willing to try it. Yeah, you just probably meet like a few people that are actually open to it. So these are the core challenges, which is why this is a very fertile ground for original research. So once I started like medical imaging research, I just feel like there are a lot of problems. So if you're like a researcher looking to do maybe things in like computer vision, there are just a lot of problems in Africa, like relating to medical imaging especially. And then you also have like original research because it's like what you're actually going through. So yeah, I think it's very crazy what we go through. But yes, So yes, for the rest of the talk, we'll just be talking about the data challenges and solutions, the model, like designing models for robustness in Africa, and then like just we are going to speak a bit about my research. I think there's a lot of research out there, but I'm just going to be speaking about what I've worked on so far and some research directions that like anybody interested in this can probably look at as well. Yeah. So I visualized a yeah, I was talking about like I think someone mentioned that yeah, they'll just be telling you like your kidney is in good shape, even when I don't know, you probably have a tumor or something. But yeah, so there's like a challenge under MICAI. So MICAI is like the biggest medical imaging conference in the world, practically. So everybody from everywhere like come together trying to like solve problems from like different continents or the world generally. So yeah, so there's this like BRAT data set from like Europe, and then there's like BRAT Africa. And then what like when you look through it, like normally you're like, okay, like MRI scans. I think when I first started working on this, I'm like, yeah, since it's MRI scans, like we don't have the problem of yeah, we don't have the problem of like skin color difference. Like there's no outward like difference. So I'm like, yeah, it's MRI, like it will definitely be the same. Like, yeah, just like bring the data sets and let me just maybe fine tune or just even train it together and just like segment the tumor or something. But then it's so crazy because when you actually like when you actually look through it very well, the difference is wild. So imagine someone having a tumor, like a tiny tumor, in this, let's say in like Africa and Europe. So look at these two MRI scans now. So imagine having like a tiny tumor in this and then having like a tiny tumor in the other one. Just seeing this other one, this is just a slice of like MRI scan. So you can just easily tell that, oh yeah, there's a problem here and segment it really well. And then in African MRIs, you can't even tell if this is a bean or something because it's just there really. So yeah, so this is like a very like major problem that is like happening in Africa. And I wanted us to see it firsthand by just visualizing this one. So yes, I went through like a paper as well, and then you see like for US data sets, you'll be seeing that the accuracy. So okay, this train SSA is like the dice score, like the percentage accuracy of like training models on our own data sets and like training this on European data sets. So you can see that our own is not even reaching like 60% accuracy, and theirs is like already 80% accuracy. And this was even like, yeah, like after like a lot of training and all of that. So I think the problem is, yeah, there's a lot of problem out there. And then so why I think a very like people could have been looking at it and saying that okay, maybe like just let's like bring out more data, like maybe like if we train like on more data sets, right? I feel like yeah, like a lot of researchers here. So if you're like, yeah, let's just bring more data and add it to our training data sets and probably train through that. But then it's really not an option, especially in medical imaging AI, because it is very expensive. It requires CAS experts. I was speaking about how most of our clinicians have jackpot. And then, yeah, retrospective data is messy, and then public data sets really reflect like local reality. So yes, as you could see, we can't really use like other data sets to quantify what is wrong with us per se. So yes, as we've seen, so there's like a data set issue that's like very known. So now we want to see how to like build models based on like the data sets we've been given. So as an African, they said as in Nigeria, they said life is already winning you 1-0. But yeah, I don't know if that's true. But we have to find a way to work with our problems, to fix our own problems, because nobody really fix it for us. Let me put it that way. So based on these problems, I think a big part of my talk today is like do you build like models based on the availability of data here in let's say Nigeria. So I'm going to just be speaking about a brief like some of my projects and why I did what I did, mostly so that you see it from like let's say my lens. So one of my projects is structure away denoising for pediatric chest x-ray. So I spoke about it then that yeah, like there's a quality drop in images once you're scanning here in Nigeria and scanning there in America, just know that your Nigerian quality is like very lower. So if they are telling you one thing, I feel like it even makes sense if you're scanning anything in Nigeria to do like a double scan or a triple scan. But yeah, so there's like a problem of quality drop. So I think a very fertile ground for research should be like just image reconstruction. Let me put it in that line. So whenever you're building like models, so initially this project just came from like just trying to classify pneumonia, just taking like a data set and trying to see, sorry, which who has pneumonia, who doesn't. So that's where this came from. But then just knowing the problems that stems from like the quality of images, so we decided to build like a denoising model for pediatric x-rays. So I think the idea is practically like, okay, what if you can get like from African images, let's say, like load those images now. Yeah, what if we can build like a denoising model that will take like an image that looks like here in Africa, and then like you feed it through your model, and then you have like an image from like the US or something. Yeah. So I think that was like the idea. So I think knowing the problems behind this just helps you like integrate that into your research. Yeah. Sorry, can someone thumbs up if you can still hear me? I just want to confirm. Oh, amazing, thank you. Yeah, so yes, so just knowing the problems, I feel like as Africans, you should just try to yes, there was a poster presentation at Shapexar at the Boyega. Yeah, that's like a very that's a very lovely notice. But yeah, so we were just trying to build something that should I say that reflected our realities and try to fix it. So I don't know if you guys know of the unit. So practically the unit works with like the unit architecture is like a very popular architecture for like a lot of tasks. If you're doing maybe like classification, segmentation, you'll probably be using units or it's like variants for your task or for like your baseline. So it's like very popular. But I think when we were building the units, there was not anything like image. Sorry, so there was nothing like image quality or anything like that. But then like building this, just having it in mind that okay, there's a problem of that. So we just worked with the original unit design, just building like an encoder decoder. So I think usually if you're using like a unit for denoising, you just use like an encoder denoiser decoder, and then you get your final x-ray. But because of how like let's say life is dealing with us 1-0, we were able to like just like put that into our architecture and then come up with this edge aware decoder. So our our model is not just only like going denoising, but it's also like being very aware of like the problems here practically. And then we also had this like Laplacian enhanced keep connections. I don't know, the paper is out there. I don't know if I want to be super technical, but my point is so just like knowing the problems that exist, I think like if you want to do research in this field, it just makes sense if you're like building models that reflect what we are going through. I think this SharpXR is like a very like should I say a very new kind of structure, particularly for like low-dose imaging. But then I think let me speak a bit more about this is the results. I'll probably save my slides, but so I think another of my project that like shows how to incorporate like the knowledge of like our realities into building our models. So you saw these two scans before. So I was trying to like build a model that practically like matched, like that wasn't 60% accuracy, that didn't have 60% accuracy, and instead had like like maybe like averaging like 80% like what they had. So I think knowing that, so I think one of the first things I did, like just from this, I knew that there was like a physical difference. So the method that we came up with, it was a new, I think I should mention like, oh, this was a neurostructure paper. So so that you people will know that. But yes, so we came up with like this so there's this tech format 3D. I might be wrong, but I think NVIDIA, someone from NVIDIA, maybe someone from Google and someone from this other big place came up with this. So it's practically like a transformer for that's like very fast and not as compute expensive as other transformers. Yeah, so we now built on this, but then instead of just using seg format that these people created, we now wanted to like do something that balanced like the realities from Africa. So we introduced this histogram matching. So I think I had a diagram of histogram matching here. Yeah, perfect. So I think histogram matching, yeah, this doesn't show it well. I should have had a better picture. But what histogram matching does is practically yeah, matching the histogram, I don't know. But it just makes the physical qualities look more alike. So you're first seeing here, yeah, this is, I should have used a better image, but you get the gist. So this is like the initial like image, but then when you pass it through histogram matching with like a reference from wherever you want it to look like, so it ends up looking like more like that. So that's like one of the like things we did. So just knowing that, okay, yeah, there's this change is there, and I think once that like informs your research, it just makes your research novel. Yeah, let me put it that way. It makes your research more novel and actually like solve like the problems that we have like here in Africa, let me put it that way. We also did this radiomics guided stratified sampling. I think a lot of people that have done like Brat Africa, yeah, Brat Africa is practically a challenge for brain tumor segmentation in Africa. I think anybody interested in like medical imaging in Africa can just maybe start their research from there. So just trying to build like a segmentation model that works for African MRI scans. So I think that's like the idea. I'm just realizing that, yeah, so people might not get that. But yeah, so we did like this radiomics guided stratified sampling. So I think stratified sampling is something like this, where okay, your data set, maybe there's like a lot of differences, let me put it that way. So there's a lot of differences, and then you just like stratify it in a way. So like all these similar initial data sets, you put them together, like you put everything that have like maybe similar like shape, sizes, you put them together so that like when you're training, your model is not choosing, like it doesn't become biased because like it's choosing maybe different things from the same um for the same like shape, size for like a batch or something. So you're just having like a more well-rounded, robust kind of training. Yes. So I think the idea is just like have it at the back of your mind when you're building your models. Have like the problems that exist at the back of your mind, and just integrate that into your research. I think that's like one of the I want to say shortcuts to, not really shortcuts, but like that's really the way you can solve problems in low resource setting. Like that's the only way you can build like robust models, like just knowing the problems that exist, like mostly with your data sets, and trying to build models for them. um yes, so you can see the segmentation here, so it was way better. I'll, yeah, I think I'll leave my slides out. I think this will be posted on the ML Lagos YouTube channel as well, I don't know. Yeah, so I don't know how much time I have, so I'm just going to like brief through this. But yes, another very fertile ground for research you can do is maybe building some things like self-supervised learning, semi-supervised learning, things in that line. So yeah, so I think supervised learning works with like your whole data set all having like labels. But then when it comes to like semi-supervised, self-supervised learning, you're working with like limited labels, or yeah, let me put it that way, limited labels. So I think, so in Africa, I think there are even some places where we just have like data sets, but then all our clinicians have maybe left our country, and then the data sets are just there, but then you don't have like an annotation. So I think a very good use case of that being OCT images. So OCT images are like retinal scans. I don't know if anybody has done this before. I think this is less popular than the other medical imaging modalities. So it's like just retinal scans, and then they tend to like be hard to segment because you're looking like at this initial like image, and you're trying to like just segment through, like it's very hard to, even looking at it like just as a normal person, like you can tell that yeah, these images are very sparse, and then it's just hard to. So maybe building like stuff for this that just like that don't need annotations, yeah, that don't need labels. So that's like one of the things I did. So we just did like a I think, I don't know if you guys have heard of like masked auto encoders. So they're like MAE. So the idea behind it is practically you just mask, okay, yeah, you just like mask some part of your images, and you tell your image like, yeah, like reconstruct the image. So even though like the model is not doing what you I don't say you really want it to do, but then it's learning, okay, the image is like this. Okay, when I maxed it like this wasn't right. Sorry, when I like reconstructed it like this wasn't right. So yeah, the image probably looks more like this. So just putting it that way just helps your downstream, maybe like segmentation task. I hope I'm not speaking too technically, but yeah, it just helps like your downstream segmentation task, and it just helps with it like limited annotations and all of that. Yeah, okay, yeah. So open research question. So yeah, so how can robustness be measured across devices, hospitals, populations, and real world degradation conditions? I think I had a number of people reach out to me that yeah, they want to do research, but I think most people just don't understand like should I say the basics of how it is done, like defining your problems, yeah, even to do your research at all. So I think this questions just help you like take a look at it from a more research kind of perspective. Um, yeah, and then what's the minimum data required to train models that generalize reliably under domain shift? And yeah, how can systems detect, communicate, and adapt to silent failures after deployment over time? So I think these are some of the things that have not really been fully fleshed out in more likely in low resource AI generally. So I think when you're looking for like directions, you can maybe just start from here and like just branch out. So yeah, so thank you so much for listening to me. I think the purpose of my talk was mostly like just to see like the problems that exist where we are, and just like so that people can like have our like context in mind whenever they're like maybe building new products, building new research, doing things like that. So practically building like models that are both balanced across the world and across Africa at large. So thank you so much everybody for listening to me. I think yeah, I don't know how much time we have for questions, but this is my email, this is my Twitter down here, and this is my LinkedIn up here. Yeah, thank you so much, guys. I don't know if I should stop sharing my screen. Does anybody have any questions? I don't know if you have time for that, our organizers.
Yeah, we can just take maybe like 5 minutes for questions.
Okay.
Does anybody, Chikodiri Amos, please quickly unmute your mic and ask your question.
Hello, can you hear me?
Yeah, I can hear you.
Yes.
Okay, okay. My name is Chikodri Amos, and I'm a final year student of medical laboratory science. So, my final year project currently is almost similar to this. I'm kind of like building, like working with like YOLO and Resnet 50 for like a particular life procedure we normally do. It's like normally full blood count where you like use your microscope to like view samples. So uh currently I was like checking for data set if there was any available data set, but I didn't actually get. But so I was working like with my own custom. I had to like start labeling my own custom data set from scratch. So like it was really bad. It's painful, self. Like I'm crying because it's like it's not only me that is doing it, and like it's only me that is doing it. Let me just I'm the only one doing it, and I'm like I actually did like on 50 like 50 data set. I trained one, and it wasn't perfect, but it was showing like it's possible. I'm just like hoping on you like it's possible, but I don't actually know. So when I saw your stuff, I was very very interested. I'm like where more ways like you can connect us or something like that. Thank you.
Yeah, that's really amazing. Are you working in something in the line of medical imaging as well, or is something outside that?
Yeah, I'm working line in medical imaging, in particular,
Oh,
mostly with
that's interesting.
PyTorch.
Oh, I see. What imaging modality are you using? I want to see if I can just recommend the data set, maybe.
No, no, no. Like it's like for a like uh on that full blood count. When
Oh,
you normally do full blood counts, like you get samples from like for differential, then you get samples for like
okay.
platelets, then you
All
get
right.
sample for like white blood cell. But most of these procedures are like old procedures, but
Oh,
they're not
okay.
too common like that because the automated ones are like more common. It's mostly just common in teaching hospitals. Mostly teaching hospitals. If you ask me for friends in the lab scientists, they about differential and and this thing,
Yeah, yeah, no
platelet
problem.
count, liver chamber.
Yeah. I don't know if you want to speak a little bit or you can like speak via email, but that's like an interesting work actually.
Okay.
All right.
Okay. Yeah. Thank you.
Yeah, thank you. I don't know if anybody
Okay,
has any.
Michael, please, can you share your question? Here, there are like 4 people.
Oh,
Michael, please, can
interesting.
you share your question?
All right, thank you very much. Thank you, our facilitator. My question is basically kind of very basic because I'm a machine learning engineer, just fresh out of learning, and
Yeah.
I'm also a microbiologist. I'm not really deep into medical diagnosis really. So I've been wondering, all of this conversation have been around major medical diagnoses and some diagnoses that seems to be biomedical in nature. Take, for example, malaria microscopy is not really featuring in the conversation. And also, I want to ask a question about you mentioning about image quality variability. So, what is the root cause of that? Is it the quality of the devices we use in the scan and all of that compared to that which they use in the US? Is that a major cause of the less quality images we get here in Nigeria, or there is another cause? So those are
Okay.
the things I want to make sure.
Yeah, those are actually amazing observations, Michael. Yeah, thank you for that. So for the first thing you said about like malaria, kind of like the imaging in that line. So I feel like there's medical imaging and there's like this pathological imaging. I don't know, but they are very similar. But then pathology deals more with like I want to say cells, like yeah, observations, like trying to see like if malaria exists in this maybe like blood smear or things in that line. I think it's very similar, but yeah, very different as well. Um, but then I think for the second one, what causes the changes the most, like the differences the most, is actually in the I want to say scanners that we can afford. So even UCH has like the best scanners, but then the best scanners that we have in quotes, they're still not good enough. Like it still like creates like a sort of like variability. I think we just try to work with like a budget. So I think scanners are generally very expensive to be fair. So we can barely afford like the same ones that they're using there in the US. Yeah.
Right. All right. Thank you very much. I would like to reach out to you personally because I'm doing quite a lot of stuff around that um, pathology imaging kind of thing. And you being an independent researcher, I really want to learn how to tread that path because I'm not currently in any academic institution, and I am
Oh,
really willing to do stuff.
yeah, you can
So
also join
I would,
ML Collective, I think. So yeah. So I think anybody that wants to do research generally can just join ML Collective. I think I started running research on that there. So you can just Google search ML Collective. There's like a Discord server attached to the website you see there. And I'm very open. I think anybody can just send me an email. Yeah,
all right.
thank
Thank you
you.
very much.
I don't know our
Okay,
organizers, do we have more
thank
time for
you,
the
Michael.
questions?
We really don't have so much time, so we're just going to take 2 more questions. That's Victor and Tayo. I mean, sorry, Victor, Tayo, and Osari. Except if you want us to take the other question. But Victor, please, can you go ahead and ask your question?
Hi, yeah, Larry, can you hear me?
Yeah, I can hear you well.
Oh, thank you for the invitation. My name is Victor. I'm a early career doctor. Yes. So I have like 2 questions for you.
Okay.
So my first question is, you talked about the data problem, which I think is very valid. So if we are going to compare like models that we built in US, for example, and models that are built here, we have talked about the data they are shown on, right? So my first question, how are you approaching this data problem? Because I think there are all these patients do in this imaging investigation all the time. It's just not available in the way that you guys want it, I suppose. So how you approaching the data problem, getting
Sorry,
all the data that you need to train your models.
sorry, I didn't get your last
Um,
sentence.
so like how so like this data exists in a way like patients do all this investigation. Patients do X-rays, they do CT scan, they do MRIs all the time,
Yeah,
but it's just not available, I guess, in the way that you guys want to, like maybe digitally or something. I know
yeah.
you get what I'm saying. Like how you approaching it forward. And my second question is how do you imagine like in day-to-day clinical practice? Because I think it's easy to just imagine that this is going to be very useful for people, and obviously you want to use therapy in low resource settings. So like how do you imagine that this will be useful, that this will be used in like day-to-day clinical practice? Then my last question is do you have is there any, so I mentioned earlier that I early career doctor. So is there any model that is available that is built by Nigerians or from Nigerian data that we can like try or just try out or something, see how well it works. So I don't know if you
Oh,
get what I'm saying.
yeah. Thank you, Victor Tayo.
Yeah.
So I think I got your questions, but I don't think I got the first one. So let me just start from the other two. I'll come back to the first. So yeah, for the second one, I think you spoke about maybe something in the line of how do we imagine, or maybe this is the last one. Yeah, how do we imagine it being used like in the real world or something like that, like what we're building. So I think there's this lab. So I mentioned I was under Spark Academy. So Spark Academy is sort of like affiliated with this My Labs. So there's this Lagos Medical Artificial Intelligence Lab or something in that line. So and I think those like just being with them, just like as I just helped me see. So I think what they're doing is very amazing. I think they're one of the biggest medical imaging like engineering like companies in Nigeria or something. So most of the models that we build for like Brass Africa. So Brass Africa, I spoke about it before, is like tumor segmentation in Africa. So most of what we do here, they sort of like actually use the models for their task in their lab. So they do like a lot of like medical imaging tasks. So they just use most of the model. They just look at the research, so look at challenges, like look at what is being done, and then they just pick the tops and like use it for their own like lab. So imagine like if you're segmenting a tumor normally, like with like a doctor like trying to annotate an MRI scan and trying to segment it on his or her own, actually like takes like a lot of time. I'm not a clinician, but I'm going to average like 3 hours in my head because it's like 3D, but then you just have like a model and then you're just like feeding it. I don't think I know the intricacies of how they actually like embed it into, but I know it's being used. So and then like this like segmentation just happens in like a few seconds um for each MRI scan. So I think the difference is actually crazy, and I know it is being used mostly because I've been like affiliated with them. And then I think what else do you speak about? Oh yeah, you
So
mentioned like
like is there any model like that is available that can be tried out?
yeah, there are a lot of models.
Like I mean, okay.
Yeah, there are a lot of I think most like the challenge I worked on Brass Africa, so they sort of mandate you to like put your model out there so that people use it. So I think you just have to do like one or two Google searches, just like or just check through papers. I think most of the papers they just link their code within it. Yeah. So yeah, I think that's like the best way to find it. So when you link their code, like most of the codes, they just have like their weights on the GitHub as well. So I think that's like a very like useful thing as well. I hope I
All right, thank you very much. Thank you very much.
all right, thank you, Victor. I think one more question. I'll try to answer Marvelous's as well.
Okay, so I mean, we're going to take the three questions from the people that raised their hands, and that will be it. So,
All right.
can Osare please? Can you go?
Hello, good
Is that
evening.
okay, Larry?
Oh, amazing.
Yeah.
Yeah. Good evening, Osiri.
Good evening, please. My name is Osebekli. You can call me Osebekli, that's fine. Um, I'm a medical. I'm a medical student and I'm a computer graphics engineer. I'm currently researching in the field of computational neuroscience. And one of the things that when you were talking about in Hilary in your presentation was it seems that your data is mostly of African context. So my question is, because for me now, what I'm working on is 3D pipeline for MRI segmentation with brains. But the data that that's available to me is usually from Open Neuro or Brain. Their data from abroad. They are the ones that are high quality. So if I wanted to
Okay.
get the African context, where would I be able to find high quality MRI images that will fit this problem for me?
Oh, yeah. Sorry, I didn't really get your name, but then so yeah, amazing question, and really nice to see that someone is like working in this like field as well. So I think the one I was speaking about, so there's like the Brat Africa data set. I think it consists of about 60 to 100 like yeah, not high quality, because they say high quality data set. African is not high quality, but then yeah, they've been pre-processed and all. So I think if you just check for Brass Africa dataset on Google, you probably see it. But a more detailed answer would be, I think there's this synapse.org, and then I know that that's where like the Brass Africa dataset is hosted as well. But then I think you can just do like a Google search of like Brass Africa. I think there are either papers or they will just bring up this. Yeah, you can just maybe Brass Africa dataset on Synapse, and you probably see the link easily. Let me try to type it in on chat as well. Oh, okay. Right, Africa Synapse datasets. Yeah. So I just sent it on chat. I hope that's good. You're welcome. Yeah, I think the next person can like carry on.
Caleb, please, can you unmute and ask your question, please?
Good evening.
Good evening.
Yeah, I think you already answered my question. I wanted to ask, like, where do you source for this data that you use to train your models? So I think you already answered that. Thank you.
Oh, amazing. You're welcome. I think OBG can go next. I hope I got the pronunciation.
Okay, good evening to you all. Thank you, moderator, and also this night our webinar instructor for today. Thank you so much. I really appreciate this wonderful time which you shared to us. My question is, how can we, that is, let me just say basic, that are not, that want to start, where can we start in terms of machine learning in AI? Such as I'm very interested, but the basic issue there is where to start. Maybe after lecture like this, what next that can guide us, especially mentoring, not starting is the issue, but you also need someone that can also mentor and also guide you on what and what to do. So there are some I normally watch on YouTube, but I don't actually understand it. I also need someone to guide me and put me through it. Thank you so much.
All right. OBG, thank you so much for that. So I feel like the first thing I would have recommended is probably ML Collective. But I think ML Collective works best when you have like a sort of like background yourself. But yeah, I want to say there are a number of like roadmaps out there. I think for one, like being in ML Lagos, being in this space is actually like a very big plus. Like just being part of communities like helps you, especially when you have questions, and then you can just like give it to them, and then they'll just like help you answer your questions. Yeah, definitely. Let me see. I should probably send the slides on this chat. But yeah, so I'm trying to see if I having. I think most of the roadmaps I had there, they're just like I've outside in my head. I don't know. Yeah, but I think the general pathway is learn Python enough to like um like learn Python, go to the libraries, and then yeah, maybe join a collective by then. I feel like my answer is very big. Maybe, yeah, I think I have a roadmap that I can just like share with you. Yeah. Yeah, thank you, Samuel. That's amazing. OBJ, I
Thank
think you
you,
can.
Larry, for
Yeah,
thank you, Larry, for
thank you.
that. And also, OBJ,
I'm
if you
fighting. Yeah.
engage on the hi, Ebube Chuku, can you please mute your mic? If you engage in the community, we're currently doing a study group, and I'm sure that we're going to do another one next year. So if you stay plugged in, and then there are like two cohorts. There is the machine learning and there's the AI generative, where you can like join for the beginners. So Ilary, are you able to take the question in the chat, and that will be it from
Oh, okay.
Marvelous Amos, and
Question.
we'll just wrap up with that.
Okay, so Marvelous's question is, what is your principal process for working with these image data sets to improve the output? I believe he's asking what's your approach from an ML perspective for resolving data quality. So I think my talk sort of like covered this question a bit to like a sort of an extent. So I spoke about like working with the data quality that we have from, should I say, from three different perspectives. So maybe like building models with just like this in mind, and maybe engineering like methods that reflect this these qualities as well. And I think a very good reply will also be like the whole SSL thing, like self-supervised learning kind of thing. So I don't think I can resolve the data quality, like resolve, but I think we should just like build models that, yeah, like from the ML perspective, just building models that have like the data quality in mind. So don't just like ignore the problems that we have, but actually like use it to inform the models that you're going to build. I think that's more like it. Marvelous. I hope I answered your question.
Thank you so much. Thank you so much, Larry, for such a session. And then, I mean, this is a part, or I mean, that a lot of people are interested in, and we hope to do more of this. Since a lot of people are more interested in very practical part of AI, we're happy to have you around, and happy that you honored our invitation.
Thank you so much, Emil Legos.
Okay.
This was amazing.
I mean, do you want to share some last word before we move on?
I think, Larry. Yeah, sorry, can you hear me well? Let me turn off my camera. So I think I just want to like just share my slides before leaving, maybe on the chat or something, because I think a number of people requested it.
Okay, so you can share it in the email. So we'll share it with the community.
Oh, amazing.
And when we're doing this recorded session. Thank you so much. We'll share it with the community. So thank you so much.
Yeah, thank you so much. Yeah. I will. Yeah.
All right, thank you.
Yeah, thank you so much.
Thank you everyone for joining. Thank you. Thank you, Larry. Thank you everyone for joining. Please join Machine Learning for more updates on LinkedIn and on Twitter, that's X, for more updates in the coming year. Also, for upcoming events, we're going to, keep going on with our study group. Like Ifeanyi asks, we have like programs for beginners and for people that are also in the intermediary stage in the community. So please be engaged and follow up with the information and the messages that are shared in the group, so that you can partake of all the things that we are sharing. We recently also concluded our community day, which was also to bring us together and help us know where everybody's at, and to help know where to help build up everybody. So let's engage so that we'll get the full value of the community, right? Let's stay engaged. So for quick feedback, so that we can know how best to do better in the coming year, I'm sharing the link in the chat. Please give us your feedback. It's very important as we're planning for the next year. We see that the turn up for this topic is very, very is way much more than average than we usually have. So again, we're more interesting and practical thing for the coming year, which is year 2026. It's coming in less than 2 weeks. Yeah, and that is it. Thank you so much again for being with us all through the year and for always showing up. And then please remember to fill the feedback form so that we can improve and be better. Do not forget to follow us on LinkedIn and Twitter, X. So, I mean, we look forward to hearing more from you. And also, please remember to just engage in the group. Thank you. I'm looking forward to do more things together in 2026. Good night, everybody. Merry Christmas and Happy New Year in advance. Thank you. Thank you so much, Iliri. We appreciate you. So people, I'm going to stop recording and then turn off the call soon.